What's up, everybody? It is Saturday morning, 9:30 in the morning, and I am sitting in a commuter parking lot off of I-25. Maybe I'll tell you why in the next video. But let's get started with this one right now. Problem number 6. Explain what it means for a function to be even or odd. Explain what it means visually and algebraically. Provide an example of each. Blah, 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 blah. So, easiest way to start this off is by sketching a graph. Alright, so here we have the graph of y equals x squared. This is the most basic example of a function that shows to be an even function. It has symmetry across the vertical y-axis right there. Notice if I go 1 to the right, I go 1 up. If I go 1 to the left, I go 1 up. If I go 2 to the right, I go 4 up. If I go 2 to the left, I go 4 up. If I go 3 to the right, I go 9 up. And if I go 3 to the left, I also go 9 up. The algebraic definition of an even function is f of negative x equals f of x. Well, what does that mean? That means throwing a negative in front of whatever x value I have is not going to change what my y value will be. The x value of 1 has the same y value as the x value of negative 1. Those points right there. That's what I said a moment ago. Negative 2 and positive 2, negative 3 and positive 3. And that is true for every single point on that graph. Now, algebraically, what we could say is if we have the function f of x is x squared, well, if I want f of negative x, that's just going to be negative x quantity squared. You're just taking that spot right there, throwing a negative in front of the x inside the function, but think about what you can do with that. It doesn't matter if you square a negative number. It will be the same as the positive number squared. So negative x squared has to be exactly the same as x squared. Anytime you have an exponent, say something like this, negative x quantity to the power of n, where n is even, that will be exactly the same as just x to the power of n. And you can always simplify it. So anything that has that perfect symmetry across the line x equals 0, the vertical y-axis, that's always going to be an even function. So if you think about what that means, it means I could shift this graph up or down, and it could still have that symmetry as long as that key middle thingy is still on the y-axis. However, if I shifted that graph, say, to the side like that, I now no longer have that symmetry. Because if I, say, check the x value of, I don't know, what is this right there? Alright, so I was definitely just talking for quite some time, thinking it was recording, and it wasn't. So here are the cliff notes. Look at this yellow graph thingy I drew, a parabola, shift to the right. Compare that x value of 7, which is like right here. Compare that, which is about 6.5, to the x value of negative 7, which would be like way up there, not even on the screen because it's so big. There, clearly, negative x does not have the same y value as positive x, so it would not be even. Let's talk about odd. The easiest example of an odd function is y equals x. The definition, algebraically speaking, of an odd function is a function f of x that has the following properties, where negative f of x is the same as f of negative x. And again, what exactly does that mean? Well, it means you can plop a negative in front of the y value, and it would be the same as plopping a negative in front of the x in your function, then evaluating and getting a y value. That was weird. That didn't make sense. Let's try it another way. Let's say if we're doing y equals x, let's say we look at this x value right there. So let's say positive 4. If my x value is positive 4, I know that my y value is also positive 4. So I have the point 4, comma 4. Okay, well then what happens if I do this, f of negative x? So now I'm curious as to the point negative 4. What is the y value of negative 4? Well, if I get the y value of negative 4, I can go over 4, and you know we're going to be going down 4 to negative 4. What is that telling us? That's telling us that if I have f of 4, which we know is 4, if I take the opposite of f of 4, that will give me f of negative 4, right? The y value at x equals 4 is 4. If I make it negative, I get negative 4. The y value at negative 4 is negative 4. So that is an odd function. I want to show you one more example of an odd function. Might help make this a little more intuitive for you. All right, so here we have the graph y equals x cubed, another odd graph. This, if you look at it, think of it like this way. If you have a positive y value and a positive x value that correspond to each other, you will have the negative x value and negative y value. Positive 1, positive 1. Negative 1, negative 1. Positive 2, positive 8. Negative 2, negative 8. That is an odd function. If I let my function f of x equal x cubed, what I'm saying is f of 2 is 8, f of negative 2 is negative 8. What I'm saying is when I have opposite x values, I will get opposite y values, negative 8 and positive 8. If I have negative f of 2, I have negative 8. So f of x, if I have negative f of x, I have f of negative x. And you may have already noticed something special about this for an odd function like this. It means that if I do a horizontal reflection by throwing a negative in front of my x, I also get a vertical reflection by throwing a negative in front of my entire function. Some of you already picked up on that, which is super cool. Well, like x squared, we talked about a way you could handle the negative. If you're simplifying a function and you have something like this, negative x cubed, the fact that this is odd, what it tells you is that you can pull that negative out. We could rewrite this as negative x cubed without the parentheses. And that is how you would show algebraically that something is odd. And we'll do a couple examples of that a little bit down the road. This is called symmetry about the origin because it is like a horizontal flip with a vertical flip.